In this video, we are going to grab tangent function for the first time, okay? Sine function, cosine function is sinusoidal function like this, okay? The first one we see is graph of sine function. How do I know? This is an odd function from the origin. We have opposite direction on both the directions, so that's sine function. And below I have y equals cosine function. I can use theta or I can use x, just like this problem. So it's okay. So x is the input, y is the output, x is the input in angles, and y is the height of this sinusoidal function. Both of them are called wave function. However, tangent is different. So we are trying to see the ratio first. Sine is ratio opposite over hypotenuse. Cosine is ratio adjacent over hypotenuse. So we see same denominators, so we can cancel that out. It can be reduced opposite over adjacent, okay? Opposite over adjacent is the ratio of tangent, right? Sometimes I call this as rise over run to describe opposite from that angle and adjacent from that angle. So that is the ratio. We verify sine divided by cosine, we'll get tangent function, okay? So we are going to do division with the calculator. So I'm going to create a new function. This will be y equals tangent x, and I'm going to do division, okay? So let me have everything on one place. So let's see, which point do I need to do first? So let me go with the purple color. Here at 0, I have a circle shape and triangle shape and square and diamond like that. And the other side, what is that? Octagon or hexagon? Okay, and upside down parallelogram? No, trapezoid, right? And we have a different mark, star. Okay, so we have some different positions and we'd like to use the same positions of the input value and we'll divide. So let's plot the points here, okay? So let's start with the 0, 1 here. 0. At 0 angle, sine value is 0, right? So 0. Divided by, what is cosine value at angle 0? 1. So 0 divided by 1, what do we get? 0. So tangent to 0 is 0. Okay? Next one. Can I do number 1 at the end here? 1. At pi over 2, what is sine value? 1. And at pi over 2, what is cosine value? 0. So let's do division. 1 divided by 0. What is it? Undefined. How do I plot the points? There is no way you can plot the points at pi over 2. So graphically, we have a vertical asymptote. Okay? Wow. Now let's look at the other side. If I go to the negative pi over 2, what is sine value? Sine value at star location is negative 1. And cosine value at star location is 0. Oh, what do we get? Undefined again. So like the other side, at negative pi over 2, tangent function has vertical asymptote. So there is a vertical asymptote. Since sine and cosine functions are periodic function, every period we do the same kind of thing, right? So for dividing, we see the same pattern again. So every pi over 2, 2 blocks in this drawing, right? And I would have same thing happens because the denominator gets 0 from the cosine, and I will get the vertical asymptote. So it's repeating. So we see periodic functions. Okay, so wow, we have lots of vertical asymptotes because of the denominator 0 from cosine function. Okay, Now let's look at other location between these 2 points, negative pi over 2 and pi over 2, and let's graph it. Let's use a calculator, okay? Now I'm looking at the triangle location. What's sine value at triangle location? 0.5 divided by, what is cosine value of the triangle location? About point, what would you like to say? 0.5, 0.8, 0.9? 0.9? This is 1, right? So let's go with the 0.9. So let's use number. 0.5 divided by 0.9, what do you get? 0.555 repeating. Okay, so star triangle 0.5, 0.999 repeat. That is almost 1, isn't it? So let me put a triangle there. Okay, triangle here. A 0.5 repeat. 0.5555. Sorry, so that was too high. 0.5 repeat here, triangle shape. And now let's do square. Square position. From the blue, what is the height of the sine function with the square location? 0.9? Okay. About, okay. And the cosine function with the square position? 0.5. Okay, let's do division. That's higher than 1, right? 1.8. Okay, so whoa, square 1.8 over here. Okay, square. That's it. Let's connect the dots and triangle and square. Nice and smooth curve. Let me make it thicker. So this is going to be the shape and arrowhead on right end. Okay, this is the curve. And the other side, let's do hexagon shape. What's the number? Negative 0.5 and divided by same position because cosine is other function, right? 0.9. So it is in the opposite direction. It will be exactly the same location on opposite direction. So that is about negative 0.555 repeats. And then next one will be negative 1 point something, right? So it's going to be star, maybe, not star, trapezoid, maybe somewhere here. So connect the dots with a nice and smooth curve, and the graph look like that. Since we have vertical asymptote, the graph of tangent function never touches the vertical asymptote on both directions. So this is the curve, and excuse me, we will see the same pattern over and over again. Okay, so copy this and click copy paste here. So let me just draw roughly. Okay, passing through this. Here's the graph. Okay, excuse all my points other than the point of inflection. I said point of inflection. And point of inflection means the shape from the left to right, concavity is changing. So this right hand side is concave up, and left hand side is concave down, and the center point is called the point of inflection. So we can graph right hand side and left hand side. Concavity is changing. I try to graph nice and smooth curve. Failed. Okay, let's try again. Okay, better. So we can see the graph like this. Okay, so this is the graph of tangent function. Now let's see, what is the domain of a tangent function? Can I say all real numbers? No, I cannot say all real numbers, right? Why? Because we have vertical asymptotes, infinitely many, right? Where are the vertical asymptotes? Pi over 2, 3 pi over 2, right? Those numbers. And negative side also. So I need to describe those, okay? All real numbers except the points where the vertical asymptote occurs. So I can describe in words, and I'll teach you how to write this in notations in the future, okay? Not today. So that is domain. What is the range of this function? By using and the behavior of this function, it will be all real numbers. That's right. What is the period of this tangent function? What is the smallest interval you see this graph as one cycle? From here to the other side, pi over 2. From here to the other side, negative pi over 2. What is the distance from this block? That will be pi. So period of tangent function is pi, not 2 pi like sine and cosine. Okay, so that is one different thing from sinusoidal function. We have vertical asymptotes, and we have a period pi.